Jupiter, Saturn, Uranus, and Neptune are not where they formed. Billions of years ago, the outer solar system looked nothing like it does today. According to a widely studied framework called the Nice Model, named for the French city where the researchers worked, the four giant planets originally formed much closer together, in a more compact and nearly circular arrangement, all packed within roughly half the span of the outer solar system today. That compact system sat surrounded by a vast disk of leftover icy debris further out, material left over from the solar system's original formation. Over time, each giant planet exchanged tiny amounts of gravitational momentum with that surrounding debris, and slowly, almost imperceptibly, their orbits began to drift apart. Earlier models had simply assumed the giant planets formed roughly where we find them today, an assumption that struggled to explain several oddities in the outer solar system's current layout. The turning point came when Jupiter and Saturn's orbits crossed a specific ratio, with Saturn completing one orbit for every two of Jupiter's, a configuration astronomers call an orbital resonance. That resonance amplified their gravitational tug on each other dramatically, and the whole outer solar system's stability broke down within a relatively short span of time. Uranus and Neptune were flung outward onto more eccentric paths, plowing through the disk of icy bodies surrounding them and scattering material in every direction, like a cue ball breaking a tightly packed rack. Some of that scattered material was thrown inward toward the Sun, adding to a wave of impacts across the inner planets, an event some researchers connect to the late heavy bombardment. Other material was flung outward and settled into what we now call the Kuiper belt, while some objects were captured into orbits locked in resonance with Neptune, and others became trapped alongside Jupiter as Trojan asteroids that still lead and trail the planet today. Almost every strange orbital pattern astronomers see among small bodies in the outer solar system traces back to this one chaotic reshuffling. What makes the Nice Model compelling isn't just that it sounds plausible. Computer simulations built on it reproduce the actual present-day orbits of the outer planets, the structure of the Kuiper belt, and the population of Trojan asteroids with striking accuracy, details that earlier, simpler models of planet formation couldn't explain. It's a rare case in planetary science where a single reshuffling event, billions of years in the past, accounts for multiple, seemingly unrelated features of the solar system we still observe today. Researchers have since refined the idea further, in updated versions sometimes called the Nice 2 model, to better match fine details of the asteroid belt and the timing of impacts on the Moon. Subscribe for more hidden history written into planetary orbits.